Welcome to Clouds.training. This is part 4 of OOPS Concepts training program. In this lesson, we will learn about constructors in classes. Constructors are the class methods that are executed automatically when the object is created. That means whenever we instantiate our class, the constructor is the method which runs first. These constructors are useful to initialize the data members of that object. A constructor can run only once when a class is created. There are various ways we can implement these constructors. Depending upon the requirement, we need to choose the right way of implementing these constructors. For that, we need to have a concrete understanding of how we can implement different types of constructors in classes and structures. To understand these various types of constructors, we will see default constructors, static constructors, instance constructors, private constructors, copy constructors. In this lesson, we want to cover each and every type of constructor with examples and explanations. It is going to be a long session, so stay tuned for that. To start with, we will be using Visual Studio Community Edition. Also, we will use the same solution from our previous lessons. Here I have opened Visual Studio. Let's add a new project to the existing solution. Let's give it a name as Constructors. Let's make it as a startup project. Here in program.cs class, I have added some comments and created regions to easily identify the difference between the topics that we are going to discuss. These regions are helpful to organize your code in a better way. Default constructors. By default, whenever a class or structure is instantiated, the first method that gets executed is the constructor. To understand that, let's create a class and name it as default class. In this class, we will add a boolean parameter and let's create the constructor. This is a parameterless constructor. The name of the constructor should match with the name of the class or structure. In this constructor, let's initialize the value of isInitialized to true. In the main method, let's instantiate the class with the new keyword into DC object. Now let's print the boolean variable to the console. Let's put a breakpoint here for the default constructor and class initialization. Click on Start. Hit F10. Here we can see that the default constructor is being executed when a class is instantiated. Now the value of isInitialized is true. It's been printed to the console. It clearly indicates that a default constructor will always be executed whenever a class is instantiated. Now let's create another constructor. This time we will pass some parameters to the constructor. For that, I'll be creating one integer variable called sum, and the default constructor is having no parameters, but in this case we are passing two parameters int I and j and assigning the value of sum to I plus j. Now let's print the value of sum to the console. Let's remove the breakpoint and run the application. Here we can see that the sum is 0. The default integer value is being displayed here as 0. Here we have never assigned any value to the sum, but it still shows 0. The reason for this is integer is a structure type. As mentioned earlier, whenever a structure or a class is instantiated, it will run the default constructor behind the scenes and the data members are initialized. In this case, integer is a value type and it must contain a value. So a default 0 value is assigned to the integer variable. In this case, let's put breakpoints for default constructor and the constructor with the parameters and run the application. We can see that a default constructor is executed. However, it has never come to the parameterized constructor. It clearly indicates that default constructor always gets executed. Now let's initialize the second constructor and pass the values 10, 20 and print out the value sum. Hit F5. The default constructor is executed. Now you need to press F10 to step over to the next line. Here the second constructor with the parameters executed and sum is returned. You can see the console value of DC2 is 30. I hope you understand the default constructors, how it is different from the parameterized constructors. This is a good example of how constructors can be created and used in classes. But in many cases, we will have requirements to initialize the constructor of a base class. For that, we can use the keyword base. Also, we might have requirement to initialize the constructor of the same class with the different parameters. So for that, we can use the keyword this. We will see these two examples now. For that, let's rename this class to base class. We will make use of the same example to understand how we can use base keyword. Let's create a child class and inherit the base class. Create a default constructor. This default constructor, when we create the instance of this class, by default, base class default constructor is executed first and then the child class default constructor. Now, how to use the base keyword? Let's comment this out and create a new definition. Here we are making use of the base keyword. Ideally, both these are doing the same. Even if we don't provide the base keyword, it will still execute the base class default constructor and then the child class default constructor. To see this in action, we can add a console log here, the message is default constructed from child class. Also we will add console message in a base class, default constructor for the base class. Now let's create an object of this child class and run the application. Let me comment this from our previous example. And here, if you remember, we have is initialized variable in our base class. Since we have inherited, we have access to the member of a base class. And we will call this and we'll see what is the value assigned to this. Start. Here we can clearly see that default constructor from the base class is executed first and child class second, and then the value is initialized to true. This is how we can make use of the base class. Now we have another method in our base class with the parameters. So how we can create that? Let's see. Now for the base keyword, we are passing the values of I and j from the child class. So in this case, it has to execute this one and some should be returned when we pass the parameters to the child class. Let's initialize it in the main program. Here we will create another object and print the value of sum to the console. And let's run the application. We can see that the constructor with the parameters from the base class is executed when we initialized it from the child class. This is how we can make use of base keyword. Now let's see the example of this keyword. This keyword is useful whenever there is a requirement to call one constructor from another constructor of the same class. For example, if I have a constructor with a single parameter here and we want to call this from the other constructor child class with multiple parameters. Here we need to comment this out. We cannot have two constructors with the same types. Let's add a message here. This keyword example constructor. Now let's initialize this in our main program. Now let's initialize the class in main method and pass the parameters 10 and 20. Here we will print the message default constructor from base class initialized, and we will print out the value here. Let's comment this and run the application. Here we can see that there are sequence of messages printed to the console. Let's analyze them one by one. Default constructor from the base class is printed first. If you remember, we have added the console message here in the base class default constructor. Second message is this keyword example constructor. This is from the child class constructor with a single parameter, which we have called from the child class constructor using this keyword. And the third message is from the main program that we have printed here. This is how we can use base and these keywords. Now let us understand what is an instance constructor. Instance constructors are useful when we need to initialize instance members when we instantiate a class using new keyword. That means in this example we have initialized boolean variable and we are initializing the variable in default constructor. This is nothing but instance constructor. Also we are passing the variables int I and j. Suppose if we have integer variables I and j and if we are initializing it in a constructor, then this is nothing but instance constructor where we initialize the instance variables while the constructor is instantiated using new keyword. Let's rename the region to default constructors and instance constructors. Now we have covered default constructors, instance constructors. Now let us see what is a private constructor. For this we'll create a new class, create regions and add one class. Name it as private constructor example class. So what is a private constructor? Private constructors are generally useful when we have static members in a class and we want to prevent the default constructor to be instantiated when we create a class object using new keyword. If you remember, let's create a private constructor in this class. Remember, if we don't create any constructor by default, behind the scenes, a default constructor is always gets initialized. We can prevent that by creating a private constructor. To easily generate a constructor in C#, we can type ctor and hit tab. Then it will by default generate a public constructor. Let's delete the access modifier public. By default, if we don't provide any access modifier, it will be treated as private. For this, I'll be adding private. Now let us try to instantiate this class using a new keyword. Since we have added a private constructor, it should not allow us to create a new instance. We can see that it is inaccessible due to its protection level. So the compiler itself will not allow us to create the instance of this class. This is an error. So let's add a static field. Age. By using this class, we can access this static member and print this to console. Let's add here we can call this using private constructor example class dot age. Since it is a static member, we don't need to create the instance of it to access it. And let's run the application. We can see that age is printed to console. That's how private constructor prevents the instantiation of a class using a new keyword. So far we have covered default constructors, instance constructors, private constructors, and now let us see how we can implement static constructors and what are the uses of static constructors. Let's add a reason and some default code here. Static constructors are used to initialize any static data, and if we want to create it only once, we can use static constructors. Let's create a constructor. For that, we will create one read-only variable called start time, and here I have assigned static to the default constructor. Here we cannot use any access modifiers for the static constructors. If I add private, it will not be allowed as access modifiers are not allowed on static constructors. Let's remove this and we will initialize the start time in the constructor here to current datetime.now, and let's print this to console. We will print the current time using .toLong time string. Also we will create two instance constructors. For that we will create two constructors, one for sum and another for multiplication. Let's create the sum and print that to console here, and another constructor for multiplication. In this we will add x, y and z, create the multiplication and print that to console. Here in the main program, now if I try to create the new object for this class, it is not allowed because static constructors are initialized by default when an instance of a class is created or when we access the static members of the class, it will automatically be created. So we don't need to use new keyword and create the object for that. Let's comment this out and we will create object 1 for our instance constructor for the sum, and also we will create another one for the multiplication. This one will accept 3 arguments for multiplication. Since we have already added log here, let's run the application. Here in the console, message from the static constructor is printed only once, even though we have created two instances of the same class. We have static constructor initialized only once. When a first object is created, the static constructor is initialized, but when the second object is created, since it is already initialized, it will not be executed again. That's how a static constructor works. There are certain limitations and conditions when we are creating static constructors. For example, a static constructor cannot be called directly. So when a class is initialized, static constructor is created only once. And as a user, we don't have control over the constructor when it has to be executed. there is another constructor which is called copy constructor. We will see this with simple example. Here I have created a class with name as a property and created one instance constructor which accepts name as a parameter. And the second constructor is a copy constructor where we pass the previous constructor object to this constructor as a parameter. Now let's create two objects with these two constructors in our main program. Here I have created two objects, object 1 and object 2. First object is an instance constructor that we have created and passed the name as a parameter. And for the second one, we have passed the object here as a parameter to the copy constructor. Now let's run the application. We can see that name has been printed from instance constructor and copy constructor. In case if we want to do any modifications for this object after creating the copy constructor, update the name to Alex and run, we can see that name is updated to Alex. The copy constructor value still is Divakar. We will upload the entire source code to the public Git repository. In this lesson, we have learned various ways of creating constructors and different types of constructors and what are the uses of it with the examples. Thank you for watching. Have a great day.